Hi all, today's notes are on exponential real-world questions, but before we get to looking at number 1 on this handout, I'm asking that you take out your notebooks because we are going to add one example as board notes. And here it is, so I would ask that you actually press pause on the video and write this down. When you press play, I will continue to work on number 1 where it says write an exponential model. So please press pause now and get this into your notebooks as board notes. Welcome back. The question reads, a new strand of the flu virus is spreading across the globe. 4,000 people are infected when the epidemic is first discovered, and 6,000 are infected 5 days later. Use the equation P equals C times E to the KT, where C is the initial amount and K is an unknown constant. And number 1 tells us to write an exponential model. So let's see how we're going to do that. We really can help give our brains a frame of reference if we first define our variables and then see which of these variables we actually have a value for. So first let's start with T and P, because that's kind of like our X and Y, right? We've got T here and P. T is time, and it's defined in days, and I know that because it says 5 days later. So T will be number of days. P will be the total number of people. Our output is always the total being modeled by the scenario, and in this case we're talking about the total number of people being infected. So P is number of people. Then we have these other variables. We've got C, K, and those are the only two we don't have listed. So let's start with C. C is given as the initial amount. So let's go back and read for information and see if we can find the initial amount of people who were infected. Well, when I read this, it tells me that 4,000 people were infected when the epidemic was first discovered. So I know C is 4,000. Now, I mentioned K, but if you notice right here, it actually tells me that K is an unknown constant. So we don't know K. Do we know something else? Well, I know that P is defined to be the total number of people. And because it's an output, we're saying the number of people at any given time. So right here, when I'm told 6,000 people are infected 5 days later, I know that that 6,000 is actually a value that I can use for P. And that 6,000 people are infected after 5 days. So let's see what happens when we take the general model given, P equals C times E to the KT. Notice how careful I am to make sure that this is in the exponent spot. And let's plug in the known information. I know P is 6,000. I know C is 4,000. And this is E to the, I don't know K, but I do know T. T is 5. Now the only unknown is K, and that's something that we can solve for. Now I know it might look a little funny to have K times 5 in this order, but with an idea to where we're headed with these, it's actually a really good idea to just leave it like that when you first set it up. So that way your brain remembers K times T. In the next step, I'll probably rearrange it, but in our setup step, make sure these models match exactly. So our first step has always been to isolate the power or log term. So in this case, when I say isolate the power term, this is my power term. To isolate it, I can divide both sides by 4,000. If you haven't gotten your calculator out yet, you definitely are going to need it, so press pause and go grab it. In your calculators, let's do 6,000 divided by 4,000, and we should get 1.5 equals E to the 5K. From here, with our solving process, we know that the inverse operation of exponents is logarithms. So we will take the log of both sides. I would like the color to stand out for you guys, so I'm actually going to set it up like so. So we're going to take the log of 1.5 and set that equal to log of e to the 5k. Now, I think I just did something right, but then I look here, is log and e inverse operations? I'm on the right track, but not quite, because the inverse of e is not log. What is it? I hope everybody is saying natural log. So we're going to take the natural log of both sides. Now I have inverse operations. Natural log of e will cancel. We will still have natural log of 1.5 on the left side. This is now equal to 5k. To finish solving for k, we will divide by 5. Again, go ahead and get that in your calculator. And we get k equals 0.081. Now that I found that unknown constant, I can finish doing what I was asked to do, which was write an exponential model. So our model will be P equals 4,000, because that's what C is, e to the 0.081 t. By the way, you could write P or you could write P of t, whatever you like better. That wraps up our board note example. Let's now look at that first example on the handout. Take a second to read it. It says, at any time t greater than or equal to 0 in days, the number of bacteria present, y, is given by y equals c times e to the kt. That should look pretty familiar, where k is a constant. The initial number of bacteria is 1,000, and the amount triples during the first 5 days. The directions are find c and k. We're also told to round k to the nearest hundredth. As we did before, let's actually start off by defining our variables. What is t? That's our input value, and then our output is y. So t and y. If I read for information, I see that the time is being measured how? How is time being measured? Well, I see that it says days. So I know that t is number of days. And then again, what are we talking about big picture here? What total are we discussing? We're not talking about people anymore. We're talking about bacteria. And it actually tells me here the number of bacteria present, y. So it's defining it for me right there. Y is bacteria. I know from our notes that C is the initial amount. And if I read for information, it tells me that the initial number of bacteria is 1,000. So I know C is 1,000. Do I know y and t? Because again, k will always be unknown, unless it's actually given to you. This k value, this constant, is always going to be unknown. Well, it tells me that the amount triples during the first 5 days. So I know that t is 5. But how do I deal with this, the amount triples? Well, it's 1,000 that's tripling. So what does that mean for my y value? If I do 1,000 times 3, I get 3,000. Just going to add this in case you want it as a note. Just like we did before, let's start off by writing our general model. Y equals c times e to the kt. And let's plug in what's known. I know 3,000 equals, c is 1,000, e to the k times 5. So we're eventually working on solving for k. What are we going to do first? Well, before we can do anything with taking the log or natural log when we have an exponential, we need to isolate that exponential term first. So in this case, we'll be dividing both sides by 1,000. We'll get 3 equals e to the 5k. Now what are we going to do? Well, next, we'll take natural log of both sides, because natural log is the inverse operation of base e. Natural log and e cancel, and that leaves us with natural log of 3 equals 5k. From here, to finish solving for k, we will divide both sides by 5. Use your calculators. Let's find out what that is. We should be getting something like 0.2197 and so on. But the direction said round to the nearest hundredths. So here's tenths. Here's the hundredth spot. So that means that k equals 0.22. Now the directions say find c and k. So I actually found c from the information given. So c is 1,000, that's all set. And now I just found k. So part A is done. We followed directions, we found c, and we found k. B says to write the model. So the original unfilled in model was y equals c e to the kt. I've found k, so now I can write the model. Y equals 1,000 e to the 0.22 t. Let's make it neater. Now C asks, by what factor will the number of bacteria have increased by in the first 10 days? 10 days is a value for what variable? Based on how I define my variables, t is days, so I know I can plug that in for t. So before we actually talk about what it means by what factor will the number of bacteria increase, let's just find out how many bacteria there are after 10 days. So we're going to be evaluating f of 10. Plugging in 10, we have 1,000 e to the 0.22 times 10. And again, go ahead and use your calculator to find out what that is. Using our calculators, we get something like 9,025.013 approximately. So now let's figure out how do we use this to help answer this question, by what factor will the number of bacteria have increased? So think about when you hear the word double. When something doubles, like if I started with 10 books and I doubled the number, it would become 20 because I multiplied by 2. If something triples, oh, and by the way, that would be a factor of 2. When something doubles, it's a factor of 2. When something triples, like if I tripled 10 books, I would have 30 books. And I could get that by doing 10 times 3. So my initial amount was what? Let's apply that chain of reasoning to this. My initial was 1,000. So how do we get from 1,000 to roughly 9,000? Well, 1,000 times 9 is 9,000. So our answer is factor of 9. I'm going to ask that you press pause and try D on your own, and then we'll see if our answers match. Press pause, and give it a try. Now, if you're joining me for a hint, I would guess that it's because this one is asking something a little different. It says, at what time t? So it's actually not giving us days. Like here, it gave us days. Now it's saying, at what time t? So this is the unknown. Will the number of bacteria have increased by a factor of 6? So my hint would be, how many bacteria are there? If it's increased by a factor of 6, you know the initial amount. How many bacteria is that, and how would you use that information? If that hint, and if you need to rewind and hear it again, is enough to help you get going, great. Otherwise, I will do it with you in just a minute. But challenge yourself. Really think about what I just said and try. Well, if it's increased by a factor of 6, I had 1,000 initial, right? Initial was 1,000. Increasing by a factor of 6 means I'm taking 1,000 and I'm multiplying by 6. So that means that now I have 6,000 bacteria, and that is a value for P. So plugging that in for P, my equation becomes 6,000 equals 1,000 e to the 0.22t. Go ahead and now press pause and solve for t if you haven't yet on your own. So depending on where you depending on where you are in that process of hints that I just gave, press pause and finish. So to finish solving this, I'm first going to isolate the exponential term. So it's going to mean I divide both sides by 1,000. So that will become 6 equals e to the 0.22t. I will take the natural log of both sides. So this becomes natural log of 6 equals, natural log and e are inverses of each other, so those cancel, equals 0.22t. And then to finish, I will divide both sides by 0.22. And we will take our calculators and let's figure out natural log of 6 divided by 0.22. We get 8.144. So our answer is 8.144 days. So during the 8th day. And number 1 is complete. At the top of the paper, I'm not sure if you noticed, it does say graded practice. So I chose to do number 1 with you to get you started. So number 1, even though there's points associated with A, B, C, and D, will not be part of the graded question set. Please, tonight, continue working on numbers 2, I believe there's 3 or 4 questions. Let's see. Number 2, 3, and 4. So there's 3 remaining questions for you to work on, and we will discuss any questions you have, but please try every question, and you should come in with this hopefully about 90% done with maybe only a couple follow-up questions to wrap these up. These will be graded practice, so if you have any questions, please send them directly to me on Remind, and avoid sharing thoughts with neighbors for this because I will be grading it for your own work, so I really want to see your thoughts and your work on this. Thanks guys, have a great night.